Okay, all good. So now, if you see here, right? I'm not sure have you observed or not, right? Uh, Here, like whatever you have seen these blocks, right? So these blocks are not a sequence, okay? Or this is not a flow chart. You can see with the help of symbol, right? So this is called as a state machine. Okay. Can you see what is the type? Type as a state machine. Okay. So in RE framework, okay, it is not being used like sequence or flowchart here. Here, inside it is there. Well, but it is not. They did not use it. They have used a state machine. Okay. So then the question is, what is the state machine, and why they have used the state machine? Why they did not use, we can say, sequence or flowchart. Okay. So now we will see what is the reason. Okay. So maybe I have this flow. I will go here and we'll see. Okay. So what is a state machine? Well, and why it is used into the RE framework. Okay. Why it is not used like a sequence or flowchart. So we'll see about it. Okay. So let's go. So this is our, we can say, flowchart. Okay. So if I type the state machine, right? There are three activities are related to the state machine. First one is state, final state, and state machine, right? So if you go to the RE framework, right, same has been used. So this is state machine, this is state, and this is a final state or end state, right? So same things are available here also. So now suppose I'm trying to add this final state or state, it is not one, right? Because it can be used only inside the state machine, right? So maybe I will remove this flowchart and I will add this state machine, right? It will also look like a flowchart, correct? And here we can use state and final state, okay? So final state means whatever your last step is there, we have to use a final state, okay? The last block. But before that, whatever is there, we have to use as a state, okay? So we'll take a small example here, right? So that we can understand the importance of state machine. I want to create a guessing number. Okay, guessing number. So what the first thing will do will generate a random number. Ask user to guess. Okay, if guess is correct, we'll mention wow, guess is correct. Okay. If it's incorrect, we'll mention wow, guess is sorry, the guess is incorrect. Incorrect. Please guess the number once again. Once again, right? So what it should happen? It should go back to step two. Okay, it should go back to the step number two, right? And again, it should follow the same pattern, okay, or same from the step. Okay, right? So let's see how can we do. Okay, so as I said, here it will be a state. Okay, here it will be a state, and the last one is the final. Now, so now it looks like this, right? So this is your state. right? It looks like this, but when you go here, right, it will look like this, right? So we can increase the area present. So we can increase this area. Okay. So this is our initialization. Okay. This is our processing, right? And this is our finance. Okay. So what is the thing we have to do? First thing, we have to generate a random. Okay. So it will be done in the initialization, right? Now I will go to the initial. When you go to the initialization, okay, it will have, or when you will go to the state, okay, it will have three sections: entry criteria, exit criteria, and transition. Okay. Same thing you can see here into the RE. See entry criteria, then exit criteria, and transition. Okay. So why it is there, right? So entry means we are doing some actions. Okay. And after the actions, right, at the end, if you want to perform any steps, those we can add into the exit. Okay. Nothing is mandatory. Only entry is enough. Okay. Exit is not mandatory. Okay. So here we have to generate a random. Okay. So now we use a assign and we'll see how to generate a random. So I will create a random. Okay. And here we'll go and we have to generate a random. Okay. Generate a random number between 0 to 5. Okay. Generate a random number between 0 to 5. Right? We can give the range 0 to 5, 0 to 10, 0 to 100, 0 to 1000, 5 to 5000, anything. Right? I will give 0 to 5. Okay. Right? So what it will do? It will generate the number between 0 to. Okay. This number we have to do the comparison. Right? So it should be a integer. Okay. It should be a integer. Now it is giving here. Okay. Why? Because it is using dot to string. So dot to string should not be using. Okay. And then the next question may be from you people. Why it took that dot to string? Because this variable it consider as a initially we have mentioned as a string, right? That's the reason it thought like it has to store into the string variable. But initially itself, if you keep it as an integer, it will not mention that dot to string. Okay, save it. Okay, that error will go. So now just for our reference purpose, okay, we will add a log message. Log, okay, and we'll mention the random number. Okay, and this is for information, right? So that we'll understand what random number generated, right? Then only we'll be able to conclude it work perfectly or not, right? So this is just for our reference. Okay. Then with the initialization, in the processing step, what we will do? We'll take the input from the user. Okay. Like we'll ask the user to guess the number, right? Then we'll compare it. If both numbers are equal, we'll mention, we'll go to the final step, right? But if not, right, what we will do? We will uh, mention the message is incorrect. Please guess the number again. And again, it should give the message input dialog for the user, right? So I will use here input time. Okay. So type is the number. Okay. Label will mention yes. Okay. Then we have to store this into the variable. Right. So this should be also a number. Yes. go to them. This should also empty, right? Now we don't have anything related to the exit, right? So we'll keep as now. What is the thing? If both the number are equal, right? Then it should be a correct condition, right? So we have to give the condition. But before that, we have to increase the scope. We have to use outside. I will mention it as a statement. So that's here also we can take it, right? So can you see this T2, right? And click on the T2, go to the property. Okay, so it's like a condition. Can you see? Right? So here we can give the condition. What condition? Case number is equal to random number, right? Case number is equal to random number. If both numbers are equal, right? Then it will go here, right? Case is equal to random. Okay? And after that, we have to display the message. So double click on the final state, and here will display a message. So you can see end state have only entry criteria. It don't have any exit criteria. It don't have transition. Why? We will see. Okay. So here we can mention wow is correct. Okay. Then, clear, right? Now we have to able to give this correct condition. But what about another condition if it is not equal, right? So can you see this processing? Okay. It has having these nodes. Can you see when I'm moving the mouse, right? Can you see this small connectors, right? So there are three connectors are available at the top. Three connectors are available at the bottom. Three connectors are available to the left. Three connectors are available to the right. Okay. So to the state machine, we can give multiple inputs and we can take multiple outputs from there. But this is not the case with the sequence. Okay. A flowchart, we can give only one at a time. Okay. So here, what I will do, I will connect this node and will connect here itself. Okay. Similar way, we can connect whatever is available here, we can use it. So this is T, right? And here we can give the name of the node also. So this I can mention equal condition, okay, rather than T2, so we can understand easily. But T3, go here, right? Here we can mention case is not equal to, this is not equal to sign random number, right? If case is not equal to random number, right, then what it will do? We have given this condition, right? We'll give the condition name not equal, okay, not equal, and just double click. Can you see the same screen we are able to see into the statement, right? So here we can provide an action also, like what action we have to take, right? So if both are not equal, take this message box, okay, and we can mention here this is incorrect, this is incorrect, okay. Right? Similar way, if you have more than one condition, again we can do the condition here, right? But this is not possible if you take normal sequence of project. Now we can run. Okay, so 3 is a random number. I will give here as 1. Can you see what it is saying? This is incorrect. Please guess the number once again. Okay, then I will give 3. So it will mention wow, the case is done. Okay. So because of this capability, right? Uh, in the RE framework, state machine will use not the sequence or flowchart. One more. Here we are talking about this transition. So what do you mean by transition? Transition means it will show you how your flow is flowing from one state to another state. So it is mentioning after this T1 it will go to the processing. So just click on the processing. We'll directly jump back to the process. Now here we have two conditions. If it's equal, it is mentioned it will go to the final state. If it is not equal, it will mention it will go to the processing. Right? So in this way, it will show you how your flow is flowing from one node to the another. So these are the advantages of we use the RE, how we use the state. Clear? Any question, any doubt? So why I have taken this example? Just to explain, right, what is the state machine, what is the importance of it, and why it is used to the RE. Okay, clear? All right. So please go.